Welcome back, everybody, to AP Calc AB. Today's topics 1.6, determining limits using algebraic manipulations, and topic 1.7, selecting procedures for determining limits. Evaluating limits analytically, and then again, as last time, we're going to talk about more rules. So the following rules outline how to evaluate the limit of some rather simple functions. So we have basic limit rules. Let b and c be real numbers, and n be a positive integer. So here the first rule is pretty much the limit as x approaches c of b is equal to b. So b is a constant. So whatever the constant is just going to be equal to the same number itself as x approaches some number c. Rule number two, the limit of x as x approaches c. Again, here pretty much is just a direct substitution. Whatever you guys look on here, that's pretty much where you guys are going to go, right? So you just plug it in and that's what your value is going to be. And then the last one, if you guys notice, is just an exponent. So the limit as x approaches c of x raised to the n is equal to c raised to the n. So now let's look at some examples where we can also apply some of the previous rules that we learned on the previous lessons. So here we want to find the limits as x approaches 3 of 5. So if you guys notice here, this is a constant. So we're looking at the limits as x approaches 3 of 5. And since it's a constant, pretty much we're just going to set it equal to 5. And that's our answer. All right. Next one. Example 2, we have the limit as x approaches 2 of 4x squared plus 3. So here we have a sum and difference rule, so we can split those up. The limit as x approaches 2 of 4x squared plus the limit as x approaches 2 of 3. Now later on, you guys don't have to split them up here. I want to make sure that you guys are looking at the properties. So here, the first one, so again, we do substitution, and then we have a constant multiple. So first we plug it in, so we're going to get 4 times 2 squared, and then the limit of a constant remains a constant, so that's equal to 3. So this is going to be 4 times 4 plus 3 equals 16 plus 3, which is 19. On the next example, so we're looking again at the limit as x approaches 1 of x squared plus 4, and then everything over x plus 1. So again, we want to make sure that if we can plug everything in without having any problem, then we can go ahead and do so. So this is equal to, again, we have a quotient, so we can use a quotient rule to split these up. So the limit as x approaches 1 of x squared plus x plus 4, and then divided by the limit as x approaches 1 of x plus 1. So again, you do direct substitution, right? You plug in the 1 where you see an x, and if it doesn't cause any problems, then we're set. So we're looking at a 1 squared plus 1 plus 4, everything divided by 1 plus 1. So that's going to be 6 over 2. So our answer is positive 3. And for example 4, we want to find the limit as x approaches pi over 2 of sine of x. So this is a good idea to remind yourself of pretty much unit circle, because again, the most common ones are the ones that come up. If you guys know how to do the hand trick, perfect. If you haven't know how to do a hand trick, just you can Google or go to YouTube and look up the hand trick for trig express for the unit circle. So here we can plug it in without having any trouble. So we're looking at the sine of pi over 2, which is equal to positive 1.